In this example, we extend the idea developed in the last example of an ingenious way to count the number of subsets of a finite set. Now we have a finite set with 4 elements. Those 4 elements are w, x, y, and z. All right, so using this, this thing we did, so w, x, y, and z. Let's see, let's go ahead and look at this set here, the set containing only y. Remember, 1 is in the set, and 0 is not in the set. Okay, so looking at this set right here, that set right there, looking at that set, okay, we see that w is not there, right? X is not there, y is there, z is not there. Okay, so our code here would be 0, 0, 1, 0. Okay. Okay, now moving down to figuring out, okay, what subset of w, x, y, z is this here? Let's see. We have 0, 0, 0, 1. That means that only z is in the set. So we have z there, just the letter z. Okay, here we have, moving down to this one, here we have x and z. So x is in there, z is in there, y is not, and w is not. So our code is 0, 1, 0, 1. W, let's see, w, x, y. So we've got w, x, y, no z. Let's see, that would be 1, 1, 1, 0. Okay, moving down to the next one. W, x, and z. We've got 1, 1, 1, 0. So 1, 1, 0, 1. Okay. Now let's see, we've got w, y, and z. So w, no x, a y, and a z. So 1, 0, 1, 1. Now here we are. Let's see, we've got x, y, z. X, y, and z, no w, so that's 0, 1, 1, 1. And lastly, we've got them all. 1, 1, 1, 1. Okay. All right, now just to make sure I cover all my bases here, and to convince you that this whole thing all works out, I'll fill in that spot there. Okay, so 2 to the 0, 2 to the 1, 2 squared, 2 cubed. All right, you'll see why I wrote that there in just a second. Okay, so 1, 1, 0, 0. Remember, this is binary. Binary over here. And then over here is going to be base 10. Okay, so 1, 1. So this is 1 times 2 cubed plus 1 times 2 squared. 0 times 2 to the 1 plus 0 times 2 to the 0. Let's see, that's 8. 8 and 4 is 12. All right, now let's move down to this one. So you got 0, 1, 0, 1, 0, 1, 0, 1. You got 0, 1, 0, 1. Let's see, that's 4 plus 1 is 5. So 5 there. And then 0, 0, 1, 1. You got 0, 0, 1, 1. So that's 2 plus 1 is 3. Okay. Now it might take you a little bit to check this, but this side, this is all subsets. This is all subsets over here. And over here, we have every number from 0 to 15 written once. We can even check that. Let's just check that. Let's use grade. Okay, you got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right, so all of these are unique. These are all unique. And so we have a one-to-one and onto function from the subsets of w, x, y, z to all the numbers between 0 and 15, all the integers between 0 and 15 inclusive. And so how many numbers are there between 0 and 15? Inclusive, right? How many are there? Let's see, there's going to be 1 through 15, right? That's 15 plus 0. So there's 16. So that means that so we have a one-to-one and onto function between the subsets of w, x, y, z and this base 10, all the base 10 numbers between 0 and 15 inclusive integers. Right, there's 16 of those numbers, so that means that there's got to be 16 subsets. 16 is 2 to the 4th. There are 4 elements here, right? So something that you've already kind of worked with already, but this shows you why it's true. This is basically a proof, an ingenious proof. Not my own, one that I got from a book that I read. Okay.